In this video, we are going to see about a CPU scheduling algorithm called the priority scheduling algorithm. In the previous videos, I have discussed about SJF scheduling and FCFS scheduling. And in this, we are going to see about the priority scheduling. So here, each and every process is associated with a priority value. So it is an integer value, or we call it as an integer number. So each and every process is having a corresponding priority value. The value will be an integer number. So here the CPU is allocated to the process with the highest priority. So as you know, in your SJF, the smallest burst, the process with the smallest burst time will be given the CPU. But here in priority scheduling, the process which is having the highest priority will be given the CPU to execute. So how I can find out whether the process is having the highest priority. So I told each and every process will be having an integer number associated with it. That decides the priority of that particular process. So smallest the number, the highest the priority. Okay. So with that, the CPU will decide whether the incoming process is having the highest priority or not. So main disadvantage when we go for the priority scheduling is that sometimes it leads the particular process to start. Here in this case, the lower priority process may never execute at all. So whenever a lower priority process tries to execute, in meanwhile, when a higher priority process comes in, once again, what the CPU will do, CPU will just throw away the lower priority process and gives the preference to the highest priority process. So sometimes some process, it may never execute at all. So that problem, we call it as starvation. So in order to overcome this starvation problem, we have a solution that we call it as aging. So the highest priority process, if it tries to execute more and more and not allowing the lower priority process to execute, in that case, we will be increasing the um, priority of the highest priority process. So in that case, it will solve this particular starvation problem. So we will see one example of how the priority scheduling works. So just see this example. Here also in priority scheduling also we have two modes. One is non-preemptive, another one is the preemptive mode. So here they have given the priority values of each and every process. So I have four different processes, and the priorities associated with each and every process is given over here. Okay. So what we will do, and next the arrival time has given, and then the burst time has given. So once you have all these things, the first thing is you have to draw the Gantt chart. Okay, so we'll start drawing the Gantt chart. So as you know, at 0th millisecond, here as you see, the first process to come in is your P1. So when is your P1 arriving? P1 is arriving at 0th millisecond. Okay, so here check the mode. The mode is non-preemptive. That means once a process comes in, even though the next process is having the highest priority, it has to wait for it because it is working in a non-preemptive mode. Okay, so the first process to come in is your P1. So P1 starts its execution. It goes till 50 milliseconds. Okay, it goes till 50 milliseconds. That is your burst time. And meanwhile, once the P1 finishes its execution, you have three processes that are there in the queue right now. You have P2 process, P3 process, and P4 process. Okay, so all the process, it is waiting in the queue for the CPU. So now the CPU will come and see which is having the highest priority. As you know, the smaller the value, the higher the priority is. Okay, so P1 already it is over. We have three more process that is there in a queue. We have to decide which one to execute first. So P3 is having the highest priority. Okay, the smaller the value, higher the priority is. So here 1 is smaller when compared to 2 and 4. So P3 is next to execute. So now P3 will execute. It keeps on executing till 20 milliseconds. Okay, sorry, 60 milliseconds. So it will be 50 plus 60. So it will be 110. Okay, and the next process to come in is P2 or P4. It will be P2 because P2 is having the priority value 2. So P2 will come and it is going to execute for 20 milliseconds. So 110 plus 20, it will be 130 milliseconds. And the last process to come in is your P4. So P4 will execute till 10 milliseconds. So it will be 130 plus 10, it will be 140 milliseconds. Okay. And now we need to find out the completion time. So completion time for each and every process. P1, when it is getting completed, it is getting completed at 50 milliseconds. And then P2 is completing at 130 milliseconds. And then your P3 gets over at 110, and then P4 completes its process at 140 milliseconds. Okay, so this is over. Once this is over, you need to find out the turnaround time, total turnaround time of each and every process. So as you know the formula, total turnaround time, how you will find out? It is the difference between your completion time and the arrival time. So completion time minus the arrival time. So you know the completion time, you know the arrival time. Okay, so this is 50 minus 0, it will be 50. And then 130 minus 3 is 127. And then 110 minus 4, okay, it is 106. And then 140 minus 9, it is 131. So total turnaround time is over. Okay, then the next one which we have to find out is the waiting time. So you know the formula for waiting time also. What is the formula? Waiting time is equal to total turnaround time minus the burst time, right? So total turnaround time we have and burst time also we have. Subtract it and take the values. So total turnaround time is 50 minus the burst time is 50. This is 0. And then it is 127 minus 20. 127 minus 20 is 107. And then 106 minus 60. 106 minus 60 is 46. 106 minus 60 is 46. And then what we have is 131 minus 10. That is 121. Okay, so the waiting time is over right now. And then the next one which we have to see is the calculate is the average waiting time. So how we will find out the average waiting time? Add all this divided by the total number of processes. So 0 plus 107 plus 46 plus 121 divided by 4. So it will be around 68.5 milliseconds. And the next one which you have to find out is the average total turnaround time. So add everything. So it will be 50 plus 127 plus 106 plus 131 divided by 4. Okay, so it will be 103.5 milliseconds. 103.5 milliseconds. So this is how the priority scheduling works in the non-preemptive mode. So in the next video, we'll be seeing about the same priority scheduling process in a preemptive mode. Thank you.